Okay, so this entry ticket is going to continue discussing concepts of limits. We're going to review arithmetic functions, and we're going to talk about intermediate value theorem. The problem here, recall that Mr. Klee's daughter took a drug called propafenone to control her heart arrhythmia. Every 8 hours, she took a 50 milligram dose. The medicine would decay at a rate of about 11% per hour. So over 8 hours, 0.89, 89% is the percent left over, 100 minus 11, 89. 0.89 to the 8th, over an 8 hour period, about 39.4% of the medicine would still remain. So what's ultimately going on, jump to our calculator here, 0.394 of it's left over, and then she takes another dose. So now it's 69.7. That decays, 0.394 of now a bigger number is left over. So now it's 27 something. That decays. She takes another dose. So this is starting to go up. Okay. Goes down and then goes back up. Ultimately, it's a piecewise function. We'll have a broken graph, but that doesn't mean intermediate value theorem never applies. You need to check intervals, and we'll get to that in a moment. So answering number one there. Now, use that recursive rule, and you'd get all the numbers on this table. And how you use that, and we want to know what is the long-term limit of propafenone, round it to the nearest tenth of a milligram. So to use that recursive rule, you type in 50, you hit enter, you multiply it by 0.394, and you add the 50. You're keeping 39.4% of the medicine, and you're adding 50 more milligrams. So that is 8 hours, 16, 24, 32, 40, 48, and those are the numbers that you are seeing in the table, okay? And if I keep hitting enter long enough, the number is basically not changing anymore. So we would have 82 and 508 thousandths of a milligram, 82.508. Okay, so now using intermediate value theorem, does a value of 80 milligrams happen between hours 8 and 16? Okay. Will it happen in between there? So what's really happening with the graph? Let's see if I can make this somewhat accurate. There's a 0 hour, there's one 8 hour period, a second one, a third one, a fourth one, and we'll eventually talk up to a fifth one with 5 8 hour periods being 40 hours total. All right. So we start off, let's put a Y scale out here yet. Let's make that 90, which means 45 is right around there. Okay. So we start off as she takes the medicine. We're at 50. It decays. We're going to get down to 19.7. So intermediate value theorem for 0 to 8 hours says we're going to get a number between 50 and 19.7 because we're continuous over that span. All right. She's at 19.7, and she's going to take 50 more milligrams. So at after 1 8 hour time period, she is now going to be a little higher up here at 69.7. And then that's going to decay again. 39.47 of it is going to be left over. So it's going to drop down to 27. We'll go 27.4. So that would be 16 hours. So right now, we got to ask ourselves, is it continuous? So our answer for number 2, yes, continuous. The function is continuous from 8 hours to 16 hours. But 80 is not. in that range. Okay. There's no 80 in there. And it's continuous. Okay. So number 2's answer. If we talk 0 to 24 now, I don't want to clear all of it. So number 3 asks, what about 0 to 24? Well, I'm going to add to the graph here. But the idea, she's at 27.4. She takes 50 more milligrams. She's now going to be at 77.4. That's going to decay. It'll drop down to 30.5. So the lower limit keeps on going up. The higher limit keeps going up. The range in between stays at constant 50. Well, here's the problem. From 0 to 24, the graph is not continuous. So that 80.5, that's not going to happen until exactly the 24th hour. And actually, a value of 80 is never really going to happen. If I go with on-rounded numbers on my calculator real quick, we are going to get, oops, wrong calculation there. We're going to get the numbers in the table. 80 is not going to actually happen. And not only is it like, the misconception is it's going to happen, but it's going to be continuous. What's going to happen? We're going to shoot up 50 more. She's going to go immediately from 30.5 to 80.5 at the start of the third 8-hour time period / 24 hours. Okay. So because it's not continuous, it's not going to happen. And the last part, what is at least one value that should happen between 32 and 40 hours? So the last problem here is indeed continuous. We know at a 4-hour time period, we are going to start off at 81.7. And we know that that's going to decay. So it's going to drop all the way, and this graph's not perfect by any means. It's going to drop all the way to 32.18. So we got a bunch of values we could pick in there. We could say 80.1. We could say 81.65. We could say 32.2. Any number is in between there. So anything ultimately 81.7 needs to be greater than our number that we say, x, which needs to be greater than the 32.18 or so, depending on the exact rounding that you want to do there. So a lot of options. You got ultimately a range of about 50 in between, where this is continuous from 4 hours, from 4 8-hour time periods / 32 hours to 5 8-hour time periods / 40 hours. So we can have an answer. Thanks for checking this out. Please do your best on finishing up the practices.